Hi, good morning or good afternoon. So today we are going to continue with notes today, even though Miss Crawley is out. So you're going to be watching this through Edpuzzle, and you're going to have questions throughout popping up just like a normal Edpuzzle. That will be a quiz grade. You have guided notes you should have picked up from the front of the room that go along with these notes. Afterwards, you will be working on a symbiotic relationship practice worksheet. It is front and back. The next slide will have your warm ups. You need to make sure you have your warm up sheet out. And remember to continue to study for your test on Friday, which involves oceans, ecosystems, and food chains. If you were not here yesterday, if you were on the trip or you were just absent or you were sick, you should have on the desk, you should need to grab a study guide off the desk. It is front and back. We'll be going over it. Well, Ms. Crowley will be going over it on Thursday. We'll be doing another review activity. Your warm ups from today and through Thursday will be actually questions from your test. Okay, so you'll have questions that you have seen before. So on Friday, you'll be prepared. You may be able to see them, but you will not see them through your warm up sheets because you'll be turning those in before. Try to write the questions down as well. Don't just write the letter answer choice. Okay. So your four warm up questions today. Number one, which is true of all marine ecosystems? Is it A, all marine ecosystems depend on sunlight for energy? B, all marine ecosystems depend on chemicals for energy? C, all marine organisms are adapted to thrive in salt water? Or D, all marine ecosystems are adapted to thrive in cold water? Think about a marine. Marine means water. Ecosystems, you all know what it is. We've covered it last week, and you learned about it in fifth grade too. So make sure you have your answer choice. We'll go over the answers afterwards. Number two, which best describes the shallow water ocean zone? Now, it was not exactly an ocean zone title, but you should know what the word shallow means. Um, Answer choice is A, the long water column protects small organisms from being eaten by large predators. B, cooler water temperatures cause a decrease in dissolved oxygen needed by organisms. C, sunlight penetration increases algae growth and provides food for a variety of organisms. Or D, hydrothermal vents provide heat and dissolved minerals needed by some organisms to survive. Number three, upwelling moves the water of a deep ocean to the ocean's surface. What does upwelling move to the surface? Is it fish, nutrients, or phytoplankton? The answer is obviously B, nutrients. Think about upwelling. The water brings the nutrients up to the top. At night, most of the organisms that stay at the bottom of the ocean or midway, they go to the top at night because they can't deal with the sunlight like vampires, and they go get for food. That's the easiest way to remember it. Upwelling, the water is going up, bringing all the nutrients to the top. And then number four, in which location would fishermen most likely catch a greater number of fish? Is it A, at the shoreline, B, in an upwelling, C, in an intertidal zone, or D, on the deep ocean floor? This question is really common sense and is also a process of elimination you can use. We know the deep ocean floor, we want to eliminate it. Fishermen can't get to the deep ocean floor in order to get those fish. Okay, so you can cross out D. At the shoreline, have you ever seen in a movie fishermen go stay at the shore to gather their fish? No. When we go to the beach, do the fish are fish at our feet? No. So that's process of elimination as well. So you can mark out A and D. So let's do two answer choices. Look at your previous question, okay? We talked about upwelling, and it brings the nutrients to the top. So if it brings the nutrients to the top, we know that fish will also go there as well because that's where their food is. So your answer choice would also be upwelling. Okay. So answer is C, all marine organisms are adapted to thrive in salt water. Number two, sunlight penetrates, increasing the algae growth and provides food for a variety of organisms. And number three is obviously nutrients. And number four is upwelling. Now make sure you have your guided note sheet out. It is front and back, and we'll continue with notes. On this slide is just a song, a cool song that you all have seen before in the notes from last week, but it's a different song with ecosystems. I'll play it, but I'll also provide the link at the end. I'll just play a little bit of it.
Ecology, how the living interacts with their home, where they meet, eat, and greet other species in biomes, and the place where an organism lives. Habitat provides the things an organism needs. Organism of one species, population, species grouping, more population.
All right, I'll send the link out for that, okay? All right, let's go to the next slide. So interactions. So organisms interact within an ecosystem, and it's called symbiosis. And that's interactions that benefit long term and is for survival. Okay, so it's long term survival of one or both species. And symbiosis also means living together. Okay. Um, so you have commensalism, you have mutualism, and parasitism. And this was actually talked about in your worksheets from yesterday. If you weren't here yesterday, you'll get more information on it today to help you on yesterday's. But we mentioned this in your notes from last week just briefly. All right, here's another cool video I put in here talking about symbiosis. And I'll just show a small piece of it, but I'll send you all the links so you can watch it later or have Ms. Crowley show you on Thursday.
Are you familiar with the word symbiosis? It's a fancy term for a partnership between two different species, such as bees and flowers. In a symbiosis, both species depend on each other. I want to tell you about a remarkable symbiosis between a little bird, the Clark's nutcracker, and a big tree, the whitebark pine. Whitebark grow in the mountains of Wyoming, Montana, and other western states.
That was just briefly, but I'll give you all the links so you can watch it later. Populations in a food web. You all talked about food webs when y'all were in 5th grade. We talked about it briefly yesterday in the worksheet that was provided for you. But predation is the act of one organism, which is hunting or killing, feeding on another organism. So they're hunting, killing, feeding on another organism. And honestly, we do the same thing too when y'all go deer hunting or duck hunting. And things like that. But a predator is an animal that kills and eats other animals. Prey is what's being eaten by that predator. Okay. Then we have with a predation, we actually have a competition, similar to what we do when we do sports. But with this competition is organisms with similar needs. They compete for one another for a limited sources. So with food, with living space, water, air, and shelter, we do the same thing. Some of you all do it in the cafeteria with food, with your space, water, air, and shelter. These are things that organisms that live on the outside, obviously, that have to compete with. All right, so parts of a food web. So we have plants and some microorganisms are producers and they make their own food. Okay, and we talked about this yesterday in that worksheet when you had the little energy pyramid. Then you have all animals, including us humans, are consumers and which eat other organisms. Then you have decomposers like bacteria, fungi. They're composers, they're consumers that use waste materials and dead organisms to provide nutrients and food for themselves. Also, food webs, they identify the relationship amongst producers and consumers. Now, remember, a food web is multiple food chains that are linked together, okay? So food is energy. We need food in order to survive. We need food to give us energy. Same thing with producers and consumers. Food provides molecules that serve as fuel and building material for all organisms. So here's a picture of your sun that's giving us the natural energy for our producers, like our plants. They give off heat. They're eaten by the consumers and used by the decomposers. The decomposers then, obviously, they give off heat and they actually provide nutrients for the producers, which are the plants and the trees. The consumers, we give off heat, our energy, and like I said earlier, it provides for the decomposers. So energy in ecosystems. For ecosystems, a major source of food energy comes from our sunlight. And the sun supplies the energy that fuels life. Energy entering ecosystems as sunlight is transferred by producers. And a chemical energy, which we all know as photosynthesis. Plants use this. Plants use food to make immediate or store it for later. Consumers like us, we eat plants, break down the plant structures to produce the materials and energy that's needed for them to survive. The cycle is always going to continue because organisms are being decomposed, and after death, to return food materials to the environment, um, just like the previous picture. All right, so energy is cycled. So the law of conservation of energy, just like we talked about law of conservation of mass, matter cannot be created nor destroyed. Energy is never created nor is it ever destroyed. And energy can change from one form to another in living things. So ecologists that study the ecosystem, they use those food chains, those linear chains that make a food web to model how matter is being distributed and energy within that ecosystem. Matter, which we all know, in the form of nutrients, also moves through the organisms in each level. So you have your producer, your primary consumer, your secondary consumer, and your tertiary consumer. Matter is also constantly being recycled. Just like the water cycle, it can never be created nor destroyed. So how it flows through the ecosystem, those organisms in the food web and food chains make their own nutrients. We know they're called autotrophs. And those are the producers, like the plants, and the terrestrial autotrophs. Remember, terrestrial means on the land. And some unicellular organisms make up their own nutrients. And this is with photosynthesis and chemosynthesis. The consumer, us, is a heterotroph. We don't make our own food necessarily with photosynthesis, but we obtain other food in order to get our energy by eating other organisms. All right, here's another small clip on food chains. Briefly, I'll show it and then I'll move on to the next.
An ecosystem is a community of living and non-living things that work together. If there isn't enough light or water or food and something in that system dies, all the plants or animals that depend on them will die. All the parts.
All right, and I'll give you all the links to that as well. All right, so nutrient cycles, basically I put this example in there. So think about picking a pear from a tree and you eat it. You are consuming carbon, nitrogen, and other elements that the tree has used to produce that fruit. That pear that you would eat also contains energy from the sunlight trapped by the tree's leaves with photosynthesis while the pear was growing and ripening. So each organism in that food chain represents a feeding level in the passage of energy and materials. And you were briefed on that yesterday. A food web also is more a realistic web than a food chain because most organisms depend on more than one species for food. These food webs also show how energy is lost from one level to the next. This energy is lost in the environment as heat, like the picture I showed you before. It gives off heat generated by our bodies or the organisms' bodies processes of organisms. So the carbon cycle. We're going to talk about two different cycles, the carbon cycle and the nitrogen cycle. And tomorrow you're going to be doing a web quest on the carbon cycle and the nitrogen cycle, and then you will have homework. This will also be on your test. So carbon cycles, all life on Earth is based on carbon molecules, like on the periodic table. It is the symbol C, and it has actually 6 protons, 6 electrons, and 12 neutrons. But we'll talk about that later. So atoms of carbon form the framework of proteins, carbohydrates, fats, and other important molecules. More than any other element, carbon is the molecule of life. Yes, we need oxygen, but for life, for photosynthesis to occur, for us to get those proteins and carbohydrates and fats and other molecules, carbon is that molecule that we will need. The carbon cycle starts with autotrophs. And remember, autotrophs automatically make their own food. There is a Brain Pop segment on this, and I will show it really briefly, and then again, I will give you the link and with the login information. Oh, it didn't open, but I'll send you all that information. The carbon cycle also, with the autotrophs and the heterotrophs. Remember, heterotrophs are like us. We don't produce our own food necessarily. We use the carbon molecules for energy, and the carbon dioxide that is released from our bodies. 'Cause remember, we breathe in oxygen, we breathe out carbon dioxide. Remember, plants do the opposite. They breathe in carbon dioxide and they release oxygen. That's how we get our oxygen as well. And it's returned into the atmosphere. It's just like I said, it's one big cycle. Okay. It's never created nor destroyed. Just think about that. Remember, science is always common sense. So here's also a picture of the carbon cycle, how carbon dioxide in the atmosphere is used in photosynthesis to produce carbohydrates. Maybe that's not the right color to use. Let's change it to a red. Carbon is in the atmosphere. It goes into our trees, it then gives off. Okay. Also, the trees are eaten by other animals. Those animals release it back into the atmosphere for respiration, for us to be able to breathe and for plants to live as well. And carbon is released from the atmosphere from fossil fuels that are being burned, like our vehicles, cars, businesses, plants, plants like factory plants. The carbon dioxide in decaying matter and in waste, as you can see at the bottom, are being used from the plants and production, and then carbon dioxide and fossil fuels from coal and oil. All right, so the nitrogen cycle, after you eat your food, we convert those proteins in our food into proteins used in humans. So urine, basically animal waste like us too, contain excess nitrogen. When that animal urinates or pees, it returns to the soil or the water. That's why you see when dogs urinate or animals urinate, that patch of yellow or the green, it's decaying that. Is killing it. So the bacteria in the ground transforms much of that nitrogen that has been given off so that it can be stored and used by plants while returning some of it to the air. When organisms die, their nitrogen molecules are recycled. And there's another brain pop here, but I will, like I said, I'll give you those links and I'll show those to you. And here is an amoeba sisters, referring to the carbon and the nitrogen cycles. I'll show a brief clip and then we will, and I'll send you that link as well.
So last weekend, my family bought something pretty cool. Something I'm sure that you've always wanted. No, it's not a pony. It's a rotating compost bin. Yes, it's for compost and it rotates, which is going to be so awesome because the rotating part, that allows it to get aeration. You may already know about compost. It's where biodegradable things can decompose, and the whole idea is after decomposing, the result is this nutrient-rich organic material that you can provide your plants with. So I'm thinking after a while of adding leaves, banana peels, grass clippings, twigs, overripe fruit. I could keep going. After all these items break down and decompose, I'm hoping to get some nutrient-rich material for my plants. So why am I even talking about this? Well, there are two major things that compost can supply plants with that are so important: carbon and nitrogen. We're going to spend some time talking about these two elements and their cycles because both of them are so important for life. With so many incredible elements on the periodic table, we don't know if it's really fair to have a favorite, but we do. It's carbon. Sorry, nitrogen, you're cool too, but why the love for carbon? Well, we really love how versatile it is.
So like I said, I'll give you these links. They are on YouTube, so you can study with them. They will be on your test. Your test will be 41 questions. You have been given a study guide in reference to the ecosystems and food chains. You have your notes from Oceans. You will see some of these questions throughout your warm-ups the next 3 days, today, tomorrow, and Thursday. I will be available on Thursday to stay after school if you need help with testing. I will also send you a Quizlet of vocabulary words to study with that will help you. Science is common sense. If you know the vocabulary words, you'll understand the questions. Remember to take your time, read each question carefully, and you'll be able to process and eliminate your answers, and you'll find the right answer choice. If you have any questions, shoot me an email. I'll be available on Thursday and today. Just let me know ahead of time so that I can make arrangements if you need me to stay today. You're going to be working now on a symbiosis relationship worksheet in reference to commensalism, mutualism, and parasitism. Remember, mutualism is when both organisms are benefiting. Think about the picture of an alligator and a bird. I know y'all seen them before. You have the bird sitting in the alligator's mouth, but the alligator is not eating that bird. Well, the alligator has food in his mouth. The bird is like the dentist, is it is actually eating the food left over and is being fed. So it's benefiting and it's also cleaning the alligator's teeth out. So both of them are benefiting. One is going to the dentist, the other one's getting fed. Commensalism is when one benefits, but the other one is not being benefited, nor is it being harmed. And then you also have parasitism. Think about a tick. A tick is benefiting from us, but we're getting harmed. We can get Lyme disease. We can get very sick. Think about a mosquito biting us. The mosquito is benefiting because it's still living. It's transporting that blood, but we can get malaria. We can get other diseases to make us sick. So that's an example of parasitism. That parasite is harming us, but they're benefiting because they're being able to live, and that's what they do. That's what the worksheets are going to be about. That will be on your test as well. Look over your ocean notes. Like I said, I'm going to send out the Quizlet probably around lunchtime, radar time, so you have time to look at that today, tomorrow, and Thursday night before your test on Friday. If you have any questions, shoot me an email, and hope you all have a great day.